Welcome to our video. We, Alex, Arnav, and David, will be explaining the scientific aspects of the book we read, called The Making of the Fittest, by Sean B. Carroll, through a series of narrations and skits. We hope you enjoy. Genomics is a comprehensive and comparative study of different species' DNA. Genomics not only plays a role in nature, but also plays a major role in humans' lives. For example, in 1979, Diana Green was severely beaten, and she testified that her husband, Kevin Green, had inflicted her injuries. Kevin Green was convicted of attempted murder. Almost 17 years later, the California Department of Justice Laboratory processed the murder scene evidence for DNA analysis and concluded that the original samples matched that of a different man, and Kevin Green was freed from prison after serving 16 years for a crime that he did not commit. In fact, that's what Sean B. Carroll talks about in this book, The Making of the Fittest. The main purpose of this book is to explain the various uses of DNA through different examples, such as DNA analysis and court cases. DNA analysis has revolutionized the criminal justice system. Many unsolvable cases are now solved regularly, including cases from the past. The power of DNA testing extends beyond the criminal justice system. Thanks to DNA science, paternity can be determined definitively, and testing can be done for markers of genetic diseases. This book tells the story of how the new science of genomics, the comprehensive and most especially the comparative study of species DNA, is profoundly expanding our knowledge of the evolution of life. Genomics allows us to peer into the evolutionary process, allowing us to see how the fittest are made. One example that Sean Carroll includes in his book is the role of humans in natural selection and arms races. The skin of a type of rough-skinned newt is covered with a toxin called TTX, or tetrodotoxin. Although TTX can kill several people, garden snakes are resistant to it. There is a variation in this predator-prey relationship, though, since TTX production among individual newts vary, and the resistance to TTX among garden snakes also varies. This is called a co-evolutionary arms race, where selection favors the more toxic newts and more resistant snakes. An arms race is an example of faster evolution, such as humans being shaped by their physical environment. Here is a short skit depicting this example. Alright, David, Arnav, I heard there's some beef, between you guys. Do you think we should arm wrestle to settle the beef?
Yeah, let's arm wrestle.
Alright, let's do it.
Left hand, alright.
Let's go. 3, 2, 1, go.
Oh no!
Oh, David, geez.
Dude, you need to go work out. You really gotta go work out.
Alright, let's go work out now.
Destroy everything! Destroy everything! Destroy everything! Obliterate what makes us one! Destroy everything!
It's time for a rematch.
I mean, you're still gonna lose it.
Uh-huh. Right, ready, set, go.
Dude, no way, dude. Alright, tomorrow we're doing this again.
Okay.
We're not gonna win this time.
Destroy everything! Decimate what brings me! Let this world with flame! Hate this, blame this!
Arnav! What are you doing?
Dude, practicing, dude.
Oh,
Practicing.
okay. Alright, go.
Alright, one last battle, dude.
You ready to take
Train
this
hard,
L,
dude.
buddy?
We'll see. 3, 2, 1, go. Yes!
In the next example, Sean Carroll talks about the everyday math of evolution, chance, selection, and time. Evolution is defined as the change over time, and the author focuses specifically on the word time a lot. In fact, one especially interesting fact that Sean Carroll brings up is that Einstein's theory of compounding interest is mathematically similar to Darwin's theory of natural selection, since growth from an origin is dramatic after years and years of compounding. This means that the small differences in individuals can add up. They are important when compounded by natural selection, and over time they add up to make larger differences between species. The problem is that while scientists do try to study natural selection, these types of experiments are difficult since they cost a lot of money and they take up lots of time. Also, when the sample size of an experiment increases, the margin of error will decrease, which means that natural selection experiments would require lots of data to sample and collect from. Basically, there is never enough time for scientists to study lengthy evolution. Carroll says natural selection acts only on what is useful for the moment. It cannot preserve what is no longer used, and it cannot predict what will be needed. Since he says that natural selection only acts on what's useful for the present, he seems to hint that natural selection doesn't remember what happened in the past, so it tends to repeat itself.
Carroll adds to this by explaining the differences between mutation and natural selection. The mutation process is blind. Natural selection is not. Mutation generates random variation, while selection sorts out the winners and losers. Since selection rejects harmful mutations and favors beneficial mutations, this also means that, in a population, positive or negative selective coefficients can indicate fitness or those who are more likely to survive. Mutations also depend on chance and time to make a larger appearance in a population, which also depends on population size. Many people associate mutations with a negative connotation, but if this were true, species would never evolve and adapt to their environments. Mutations allow natural selection to make the decisions for species. Since mutations can be both harmful or beneficial, natural selection will remove the individuals that don't adapt well, or those who receive the harmful mutations, and will allow the next generation to attempt to adapt better. Sean Carroll also takes time out of his day to explain one of the reasons as to why people doubt evolution: time. He mentions that people fail to understand the amount of time that is involved in evolution. To summarize this example that Carroll describes, he writes, "The limit to evolution is not what it is mutationally possible, but rather ecologically necessary." Here is a small skit depicting this example.
So, as we can see through the compound interest formula, natural selection and random mutations can obviously have an effect on the MC1R gene in mice turning their fur black.
But Dr. D, how can random mutations cause natural selection? Random mutations must be way too rare to cause natural selection.
Actually, if we look at the math, so say we have 10 sites for one MC1R gene. These are 10 sites that can be mutated to make a mice's fur black. And then say we have 2 genes per mouse. So that's, and then multiply it by 2 mutations for about every billion or so bases. And so that gives us about a 1 in 25 million chance of a mouse's fur being black. That doesn't seem like a lot, right? But if we factor in the population sizes and the generation sizes, that turns out to be about 1 in every 1,000 years a mouse's fur will be black. If we put that in comparison, if you try to win the Powerball, you'd only have a chance of winning 1 in every 7,500 years. So the chances of a mouse's fur turning black are much, much higher. Thus, natural selection can happen through random mutation and is mathematically feasible.
Whoa, Dr. D, that's wonderful. I never thought of it like that.
I know. Math is cool.
Sean B. Carroll seems to be very intrigued with the fact that the source of all variety comes from mutations. He even explains that there are 175 new mutations in each person out of 7 billion DNA letters. Another interesting story that Carroll walks us through is the story of the colobus monkey, which leads to the discussion of the development of color vision. Birds, insects, and other animals use ultraviolet light to find mates and food as well. All these specific traits are due to mutations and long-term evolution. These species had to adapt to their environment, so random mutations, occurring by chance, may have allowed them to do so, which explains why some mutations can be beneficial.
Although mutations and natural selection are all very important, that's not all of what DNA plays a role in. Carroll discusses with the reader about the ever-growing database of DNA information that can be used for DNA analysis in court trials and cases, and to find more information about how certain species can survive in seemingly dangerous environments, such as the Antarctic notothenoid fish. These fish live in sub-zero temperatures in the Antarctic waters, and scientists use DNA analysis to find how they can survive in these temperatures. These fish have developed an antifreeze gene, which consists of a 9-letter code that makes the antifreeze molecules, which are 4 to 55 repeats of 3 amino acids. This is a great example of the making of the fittest theory that Sean B. Carroll spends the entire book discussing, since these fish developed this gene in order to survive in frigid waters. Another very interesting theory is explained by Carroll, which may bring up the morals and ethics more than science. Earlier, we explained how people associate the word mutation with negative and destructive, which is obviously not the only case, but it's true sometimes. These species with negative or harmful mutations are removed by natural selection over time so that the next generation, or many generations down the line, will be improved, which is the overall concept for evolution. This concept or theory brought up by Carroll is contradictory with humans, since we are normally thought to accept those with disabilities, but nature removes those specific individuals from the population.
Sean Carroll brings up many interesting points of discussion in his book, ranging from the science of DNA to the ethical uses of it, especially in the aforementioned court case with Diana and Kevin Green. He also explains how humans interact with nature and vice versa using DNA, by adapting to the environment and using mutations to their advantage. We found that this book is very helpful to understand the roots of DNA and the roles that it plays in everyday life. Furthermore, we also think that this DNA can help us understand evolution and why it is real. We recommend it to anyone who is eager to understand the deeper role of DNA in all organisms. Thank you for watching, and we hope you enjoyed.